we should use learning to try to do the things we don't know how to do already. And we should program in the things or bring in the knowledge that we already do know how to do. And that's, we're going to be able to get a lot further in terms of applications. And so my initial research, actually, when I started my career, was in planning. We've now sort of worked with bringing in planning, common sense reasoning into these applications, which are very semantically rich representations, do involve background knowledge, get as far as we can there, and then look at what the gaps are. What can't we do with the planning and scheduling, common sense reasoning approaches, and then look for learning to fill the gaps. And that's sort of the perspective I've taken is if we're going to try to be practical about it, is we need to we'll always be able to get farther by combining learning with planning, learning with I would say learning and planning, but learning with semantics background knowledge than if we do either one alone. And I think it's very important that, especially in today's sort of AI environment, where there's a little bit of a bandwagon that everybody's jumping on towards just pure end-to-end learning without any knowledge, that we remember and don't lose track of the great progress that's been made in artificial intelligence over the years, that it does incorporate other forms of reasoning, and that we're all, that we should try to make sure people remain educated in those areas, and that we look for ways to combine.
Okay.
Okay. So my name is Jie Tang from Tsinghua University. So talking about semantics. So 10 years ago, I was working on semantic web. Okay, by combining, for example, machine learning and the data mining algorithm to extract information from the web, and so that we can generate some kind of semantic web. But I soon found that it's very difficult. For example, we developed a system, A-Miner. It's aminer.org, and you can check the website. And the system already has like 100 million authors and also 100 million publication information. So we can provide some kind of expert finding and also some kind of publication search function. But we soon found that the machine learning algorithm cannot completely all the tasks in this system because it's very difficult. And also machine learning, sometimes the generated information is out of date. Sometimes the information is not accurate as we thought. So I just moved to data mining. So worked on data mining in the past 10 years, and also working on social networks, particularly work on how to understand the interaction between social networks and the information networks. Because so far, the social network become more and more popular, and also we have more and more user-generated data. So I just think about it. The semantic data is not just generated by machine, not just extracted by machine learning. So basically, we have to combine the human knowledge and also the crowdsourcing information to generate the knowledge. So that's the reason probably I was invited to join the panel. So I want to say is that combine the social information and also the human efforts into the machine learning and also to generate the semantics. Okay.
Great. So great introduction, and I think thanks for actually making that reason, obviously. And then one of the other thing was also in social side, there's a rich literature and understanding in psychology, like at an individual level, but in sociology at a group level, how human behavior works, how human societies work. How can that rich knowledge be incorporated? So that's also like kind of a question, and looking forward to the ways to your work in that side. All right, so coming to the question, first question is that why machine learning is limited when exploiting only data-driven bottom-up methods. So is in a way, when we employ like the knowledge, we saw some just one example in the keynote by Professor Dietz that there was a clustering algorithm that wasn't informative enough to get you any good insight out there in a way. So in that regard, yes, we know that dimensionality is a problem. We know that getting the right set of features is very important. And so in that regard, like if we just limit ourselves to bottom up, what are the other challenges you see in terms of meaning, rather than just as explicit, like somebody says a feature, if we think about natural language? So in that regard, like to very specific, again, as a question, what are kind of specific limitations that you see when we are just doing data processing in a bottom-up way, without bringing in any aspect of top-down knowledge.
I'll just start and mention that, so I started off trying to do planning and decision support in any of these areas like water. And one of the problems was you always have human in the loop, okay? And they want to know, first is, why are you suggesting whatever you are suggesting? Why should I be going into this part of the river and not the other part, and so on? So explanation and explainability is very important. So you are doing data analysis or insight generation for people and of people data, okay, eventually. So you need to have explainability. The second thing is, people are very worried about what is the data quality. And I have time and again been questioned, what is the data and do you understand that? And my response is, do you understand data? Who understands the data best? And the answer is no one, okay? So you may have the best sensors, the best intent, and yet you don't understand your data very well. So what is the best way to assure of data quality? And that is also not surprisingly different and difficult. That is, you have multiple sources of data. If you have multiple sources of data, you can find discrepancies and so on. And then you can point, and then through association and correlation and so on, you can convince others that there is better data quality. For example, you may have collected data from river body, right? And then you are seeing some abnormality. Now, if you have taken a photograph and you have reported color and so on, it's a different modality. It's a quantitative and then there's a qualitative data, and it actually helps assure on the overall insight. So to me, having semantics is useful for having data validation, also for having human buy-in into your results and to participate in improving it.
So I would say I'm going to actually object to the question a little bit. So it's not object, but just so the question was, why is machine learning limited when exploiting data-driven bottom-up methods? I think recent events or recent history in our field has suggested that we should be careful before we say that there are any fundamental limits to what learning can do. It surprised a lot of us recently, and I don't think we know any fundamental limitations of what. I mean, there are some machine learning theory results of what is learnable and what's not learnable, but in terms of if you have enough data, you have enough computation. A lot of things that we didn't think were possible just a few years ago have turned out to be possible. So I don't think the question is how is machine learning limited? I think there's always going to be progress in machine learning, and there's always going to be sort of the current state of the art in machine learning. And in some sense, AI has always been in the business of doing what can't currently be done with just brute force computation. Now it might be AI is in the business of doing what can't be done with brute force computation and lots of data. And that frontier is going to keep pushing forwards. We're going to be able to do more and more with the data available and computation available. Bringing in knowledge will be able to push us farther. We'll always be able to keep ahead of what we can do with pure data-driven bottom-up. So I don't think there's necessarily a fundamental limit, but by combining the two, we can always stay ahead of what we could do with one or the other. That's my perspective.
Okay.
Okay, so I'm also not sure about your question actually. So when we talk about the limitation of machine learning, so if we really want to answer this question, I guess we have to think about the machine learning in some kind of application, or on the other hand, think about the machine learning itself. So if we think about it, for example, we apply machine learning to some kind of application. Basically, machine learning is just some kind of black box. For example, we can feed some kind of input to machine learning, and then machine learning generates some kind of output. So the human, for example, okay, if we say that machine learning has some kind of limitation, that means that the input probably is not good, or the output is not as good. So in this case, probably we can think about how to incorporate some kind of knowledge, like human knowledge or some kind of human interaction into the machine learning. For example, like we can generate some kind of labeled information to the machine learning. Probably that is some kind of active learning or some other thing. And also to the output, for example, if the machine generates some output and the output is not that good, and then we can also combine some kind of human knowledge and also some kind of knowledge information from the domain. And even we can combine some kind of crowdsourcing information. For example, like recently there is some kind of chatbot, and then it's somehow like this. So the human input some kind of query, and if the machine learning answers some kind of query, and if the query is not that good, and basically the application will just forward this query to some kind of human, just a real human, and the human can answer this question. That is one way to combine the machine learning with some kind of human efforts or something like that. But I don't think this is the limitation of machine learning, because machine learning is just like a black box. Okay.
So I should have made more specific that in a context, you know, that whatever current approaches that we see, like just the what example we are seeing in the last keynote itself, like within a context, actually, you know, that the kind of limitations we see in the current approaches, and we argue that, well, it's good enough, or it's not good enough. How do we improve? So it follows then in the sense that, well, if you're thinking bottom-up approaches versus top-down approaches, and if we think of structured knowledge bases which have this top-down knowledge, and that's where we saw the emergence of semantic web and the whole semantic web technologies. So in that regard, do you see that bringing because semantic web technology themselves have a lot of challenges? How do we generate a lot of structured data? How do we build good ontologies? Right, so we have challenges there itself as well. But do you see that bringing those the convergence of those with machine learning has advantage, or is kind of overkill to think about? So that's as a question, you know, anyone, Biplav, if you think is a.
So I see I'm very focused on what the end user is thinking about, right? Are they accepting the results or they are not? And one critical thing we have found is that it's never a one-time, one-directional output that you have created results and someone is taking it. They will never take your results, no matter how good it is, if they don't understand what went behind it. So it may be a good insight, it may be a good thing, but if I'm not comfortable using it, right? If I don't understand the reason behind it, then I will not use it. So for that very reason, related to that is we know about data provenance, but I would say insight provenance. So you have talked about something, you have shown some results. Now, how can you track it back to what was the reason behind those insights that you were giving? Supervised learning definitely helps us in that sense, okay? But unsupervised learning, it has made tremendous progress. So, but the problem is unsupervised learning. How do we actually get people's acceptance? Time and again, I've seen that if people are involved in participation, now this can be expert, or it can be the people itself, or through some other data modality. So I'm not saying that the ontology is the best way of giving human guidance. There might be other ways, but human guidance is very, knowledge structures are very useful for gaining human acceptance.
So I'd say, I think this is important, gaining explainability so that people understand why it's being learned, but I don't think that's necessarily, you need to do that by having a top-down semantic approach. There's also good research to be done and being done on inspecting models, learned models from data-driven bottom-up approaches to try to understand what features were learned, or what what is the sort of rules that can be extracted from the learned network. So I don't think that's necessarily a reason. Explainability is necessarily a reason to say we can't just do data bottom-up data-driven. On the other hand, I've said that I think we can get further by combining things. I could maybe say a word about how that can happen. I think one of the best ways is, in large, learning is always going to be more efficient, use less data, less computation, less time, if learning is happening in a more constrained space. And so in some of the research that I've done, and I think one of the best uses or combinations of knowledge and semantics is to constrain the search space, to say, we can plan and say, to get from point A to point B, yes, there's a sort of infinite number of possible paths, but based on knowledge and semantics, there's really only a handful that are feasible, or they're based on my current knowledge. these are the ones that are within 50% of optimal or something like that. So now let me learn among those, and we've gotten good leverage or good success by combining in this way, by using the semantics of background knowledge. And this isn't to say it's the only way of doing it, but I think limiting the learning space can be very useful in terms of getting more out of your data and more out of your computation.
Excellent point.
Okay, so probably this question can be answered from two different aspects. For example, the first aspect is that how machine learning can help, for example, semantics or semantic web. So traditionally, I mean, for example, 10 years ago, I worked on semantic web. I just want to find some data, for example, the homepage of a researcher, and design some kind of machine learning algorithm and to extract the semantics from this page. That is, I have to say, that is a traditional way. Because everyone can think about this, right? We just design some kind of black box and extract that. But recently, actually, we have another thing that is big data. So we have to leverage big data to extract the information from the web, but not from the specific page. For just one simple example, for example, we want to identify who is female or who are male researcher in this area. For example, okay, just give my name Jie Tang from Tsinghua, and am I female or male? So if we want to do that, use the traditional way, actually we cannot find that information from the homepage or from some other page. But definitely we can use the big data, for example, from the Google. We can search some kind of query like him, Jie Tang, or her, Jie Tang. We can use some kind of hints to identify this guy is a boy or this guy is just a female or something like that. I mean, we have to leverage big data and combine big data with machine learning so that we have additional advantages to help the semantics. But another thing is that the semantic web is not just like, traditionally, just like Peter mentioned, and also Peter, sorry, I just pronounced it. Okay, so mentioned, okay, so traditionally we have a top-down, but now probably we should not do the top-down. We just generate some kind of semantic information and then apply the semantic information to the application so that we can leverage it. For example, if the application requires some kind of high precision, some information with a high precision, then probably we cannot just directly use machine learning. Probably we have to think about it some other way. Okay, that is the first aspect. And another aspect is how semantic can help machine learning. Actually, there are already many research work on this field. For example, people just think about the Bayesian model and to add some kind of Bayes prior to some kind of machine learning and to help machine learning using the domain knowledge. I have to say that is very important and also very useful.
Right, and then I mean, Bayesian models can help explain also the point that Biplav was making earlier.
I'll take one step back, and I will say that even the knowledge structures which come in, right? There's a big role machine learning has to play in creating them. So earlier, there would be a human or there would be experts through some mechanism, they would create the ontology, right? But in almost any area, there's nothing like a static ontology. And there is a lot of discussion about what is a good ontology or what is a good knowledge structure. It should be evolvable. People should be, it should be up to date. Now, how do you do that? Take any area, and there is nothing like a static ontology, okay? We take cancer. How do we understand cancer? New things are coming up. We don't even understand whether coffee is good or bad, right? Every few years, there's a new study on that, or wine is good or bad, right? So knowledge structures, they're never static. So we need, using big data or other evidences, we need to continually keep updating our knowledge structures. Yet, we have to also keep in mind that people who are the end users of the insight, right, they need to have some buy-in. So there has to be a way we have to say that these are the knowledge structures that you are working with, and this is what we are showing you the new results. And eventually, whatever new results we are showing, right, it has to somehow be related with the old results, because there's never anything which is drastically new, right? We all are working. It's just that we have forgotten the past. So that's why I think that it's a good marriage, but also there is the ontology itself is not static. We need machine learning to learn from that. And then also, why is machine learning improving? Because of the knowledge structure. It may be because there are good decision-making choices which it has captured based on prior experiences, prior other information, right? Or just human expertise, which we are good at today, and learning will take 20 years to learn that later. So I think it's a synergistic marriage.
Excellent. So I think one of the lessons that we can definitely all agree, I mean, can all agree on is, yes, we need to have focus on good knowledge representation, and there can be several ways to have that knowledge representation, and then employ that constrained space for the learning idea on that. Okay, great. So I think the last question is really towards seeing this merging, this convergence going forward, because we are seeing, like, in fact, the theme of this conference itself is human aware AI. So going forward, what do you see, like 5 years down the line, the marriage of these two kinds, where we see that we have a lot of learning analytics which has already been done in terms of machine learning, better and better learning approaches, statistical learning, I mean. And we have another side where we have more knowledge representation, more explicit external knowledge bases, structured knowledge bases that's getting created, and bringing the two together for more efficient learning. So what do you see, like, where will we be? Like, we see Watson is a good example, which has tried to leverage a lot of knowledge to actually come with good results. So in that regard, we can start with you first, Tom. Either of you.
I can quickly just one sentence.
Okay.
I guess the most important thing for semantic web is that to ask ISWC, ask them question.
Well, we will send the recommendation to ISWC about it.
Sure. I think actually we talked earlier about limitations of machine learning. We should also acknowledge, I think limitations of knowledge is that it doesn't always stay up to date, and it does require, and it can be brittle.
Mm-hmm.
And I think an important area is to make sure that the knowledge that we're injecting and using can be automatically acquired, that it can be grounded, that it can stay updated. Mm-hmm. That there's going to be limitations otherwise to the knowledge bases that we're using. So I think this is sort of a machine learning perspective on how we should get knowledge, but it should there's going to be limitations if knowledge has to be hand coded in for everything. If it can be automatically generated, automatically extracted from experience and grounded in this way, it's going to be a lot more useful. Although then you might start calling it machine learning too. So I think we should there's sort of blurred lines between these. But there's limitations on both sides, and I think there's research to be done to make learning more explainable and knowledge more learnable.
Mm-hmm. Okay, that's a great quote. I think you should take forward. So what do you think?
I would not be able to kind of say that one direction will be better than the other, but I think that what is the current gap today is we don't have good integrated systems. So the cognitive architecture of you are being able to learn, then you are able to do analysis and learn insights, take action, come back, right? Closing the loop. So I think there are different branches which some have proceeded faster than others. Okay, but even if if I take the best of the machine learning results, I don't know what to do with it. Okay, and once I do with it, and given that think about human in the loop, for which we are building up the system, and then they need to benefit, and then they are giving feedback, and again there is a closed loop. So I think those systems, more and more of them will come in, and then we would have more of aware. So we will have machine learning aware of other branches of AI and vice versa. So I think that needs to happen more and more, and that will actually progress the area. That's my 2 cents.
Excellent. Professor Tang, do you have any?
Actually, it's okay. I didn't have too much to add. It's okay. I agree with both of you.
Excellent. So I think the point that we can really see, seeing like next 5 years, the focus should be like, well, how can we make knowledge also more and more structured, but in a way that we can acquire it, yes, using so many big data technologies, evidences, and so on, while at the same time also understand that how can we have that knowledge representation efficiently for the purpose of learning. I think that's also critical. And having the explanation from the machine learning side as well, and actually making it usable for humans. Yes, that definitely makes sense. One of the other thing that I would also ask, what do you guys also think about the validation of that knowledge? Because yes, we have a lot of data coming in. We are seeing, like, in last 2 years, we have so much unstructured data that has accumulated, and from that, yes, we are going towards extracting a lot more knowledge out of it, a lot of relationships out of it, so that we can have more efficient, rich representation of the relationship and the knowledge from the data. So what are the ways you think that would be good to going towards validating also? To start with
some of the applications I'm looking
so,
at, human is already involved, and to me it is validated if people are taking the end results and they are actually acting on it. And if they are not acting on it, then it's not good. There is something missing.
Okay.
Right. So
okay. System, what do you think?
Yeah, I mean, just back to the last point. The validation to me is grounding. That the data is, or that what the knowledge can be verified, verified in the real world. That it's not just given and trusted, but that it can be validated through experience. And that's again the learning perspective on knowledge.
Mm-hmm. Okay.
Okay.
Interesting. What do you think?
I think this is a very good question, actually. So this probably is a revolutionary thing in machine learning, because traditionally, okay, validation is just we generate some kind of one truth and then apply some kind of algorithm on that and say that the precision is blah blah and the core is blah blah. But I have to say that in the future we have to think about big data and also interaction between humans. So just one example, okay, so for example, the chatbot. So that is probably one way to validate the knowledge generated by human. For example, if we can extract some information from some kind of big data, and then we could have some kind of structured information, and we can apply this information to some online test, and apply the knowledge structured data to help the chatbot and communicate with people. If the people is happy, so which means if the people just continue to communicate with the chatbot, which means that, okay, this is good. Because in the future, we are facing big data. Actually, nothing is good and nothing is bad, right? But okay, we can consider such kind of chatbot. If the chatbot is successful, that is good. So that is probably some kind of new information. Yeah.
So having a validation through humans, but the variety, the types of human, I think the three we hear like the different types, and I think crowdsourcing ways, especially in the social domain, that makes sense. Great, excellent. Then I think we'll we'll invite questions from the audience. Yes.
I don't know how much it's a question, it's sort of a comment. So I'm like, following up the first two or now questions you asked. I mean, I think what Peter was saying is really true, but I want to emphasize this thing that he said about what end-to-end learning has done. Has surprised us, given enough data. But echoing what I was talking about, I actually think big data is not. It can easily lead to artificial stupidity. It's just unlimited amounts of memorization does not teach us about machine learning. And our work on language understanding and machine translation, the reason I've been pushing, for this DARPA program to do low resources is because small data is actually the true test of machine learning. I mean, let's go back to how kids learn. Kids by the age of 4 have mastered pretty much their language, their native language, pretty much grammatically, vocabulary that they need. And the question is, how much data do they need to do that? Anybody know? Has anybody asked themselves that?
Yeah. I don't know. It's a good question because, for example, if you think, I don't know, in a typical model, I think philosophy, the description of common sense and with semantic. So I'm agreeing more with Dina, no? Humans learn with a small set of data.
So
maybe.
Actually,
Yeah. So when you use the notion of big data, well, you can think in a big quantities of data, but is it good or is it necessary or is
So
for
the answer from the child language acquisition community is that on the order of 1.5 million, as well as 1.3 million words of exposure is all kids need to learn.
Okay, but it's important to point out that the kids come with a very strong prior, right? Which has also been right? It's been learned over generations, not by the individual, but there's learning nonetheless in the prior data structure that we're born with.
And this is exactly my point. So with the I don't know, were you here in the previous session?
Part of it.
What I was talking. So like the whole thing about looking for these inductive biases that come from the strong constraints. There are evolutionary reasons why we believe that we wouldn't evolve these constraints. Mm-hmm. But they're not, you know, hard-coded knowledge a priori. It's more knowledge about the kind of knowledge you can encode. Right,
and I would argue that those are learned as well, right? So it's not, they're not programmed in, right?
Well, they're learned only in the evolutionary sense.
Right.
Learned
but that's also that,
not by a single agent.
Right. But and in the same way that learning, you know, if we're going to learn to adapt to a person's preferences, we're going to have a small amount of data on that individual person, but priors that can be learned by whole populations of people. And it's the same kind of thing. You have to learn from small amounts of data. You have to have strong priors that have been learned from large amounts of data.
So this is where I'm diverging from you.
Okay.
Is that our argument is that this is not a matter of priors, that it's a matter of computational complexity. That there are things that you simply cannot do in polynomial time efficiently enough. And that is what drives the constraints.
I don't know that
and then you can
different.
always reify that into an abstract assertion based on priors, but that would be pointless.
I guess I don't understand where we're differing. I mean, I think it's two ways of saying the same thing.
I think we have to take into account the way that kids learn. They don't only learn from language, but they also learn from gestures. Yes. And from emotions.
For us, those are languages. Sign language is also language. It also has
but the way that you would process that within machine learning is completely different because you don't take into account, you know, the emotions. You don't take into account the gestures that were used to express that specific sentence or that specific verb.
We actually do our model show. And it kind of weights the data. If there's a strong emotion, this data set is maybe high.
Going back to the child analogy of learning, they actually do, it's not just language, right? They also learn from other sensors like sight, touch, smell, everything. That enriches the whole experience and enables learning, and that's not easy for machine learning algorithms, but it's good to have that goal to be able to do that. And the interesting thing I find is that they do have a lot of training time in the beginning when they're young, but then once we get older, we do have that knowledge base at some point where it becomes faster. The learning new concepts becomes faster. But it would be good to be able to incorporate such things into our models. And I do like the idea that knowledge change. So it's really important to have add some form of uncertainty into the models or some, so that you can put more intelligent decisions later on once you combine it with the experience.
I guess another question, yes.
I think one of the big problems is the getting the raw training data for machine learning. So for instance, the semantics, it's really expensive to have semantic knowledge on a specific field. And you know, the other thing, you know, is that there are other things which semantic webs and stuff where you can pull a whole lot of general knowledge in, but it's not related to it. So for instance, in your case with Boston, there's psych, common sense knowledge. So how, I guess the question is, how can you make up for the scarcity and the high cost special semantic knowledge by leveraging other data sets that are not as specific.
You
That's a
can
good
do some
question.
transfer
Yeah,
or language machine translation, but in terms of knowledge translation.
I think it's an important question from expressivity point of view. So any comments before we take any other question? Any comments on this particular part of expressivity?
I don't have a specific comment, but I just want to point out that people have been trying to learn knowledge structures from other data sources. And whether it is from text, it is from software artifacts like UML and so on. Okay. So that's all.
Okay, I think it was before. So yes, go ahead.
I have a comment on this. So I think in addition to thinking about integrating semantics and knowledge into the process of learning, we should also think about how we integrate them into the process of teaching. Think about the kids' education. They are not really purely learning from examples. We have a full education system to give them basic structure, framework of the model, etc. So basically, I guess if we change the way of training the models, not only give them examples, but also give them the framework, the world model, etc., they can learn more effectively from small samples.
Mm-hmm. So I think that relates to perhaps Peter's point about constraint space. And yeah.
Yeah, and we actually have a
So-
student, Sami Navarkar, who's working on what we're calling curriculum learning, but trying to come up with the sort of scaffolding of tasks that can be learned by a transfer learning agent from early, in the context of using reinforcement learning, but figuring out automatically what are the tasks that they should learn first, and then use transfer learning to move to the next one.
But basically, we still look at the problem from the perspective of learning. Maybe we should also think about reinforcement teaching, online teaching, curriculum teaching.
Yes, please.
I have a quick question.
Okay.
I think for human, you can teach them how to learn, but I think, at least I haven't seen it. I think it would be important to teach machine how to learn, not learn specifically, but figure out a way to learn that thing. So it's like you teach them how to fish, okay, instead of feeding them the fish. I think humans, like kids, they are capable. Okay, you teach them, well, this is how you learn thing, and then you can apply. But no machine learning algorithm are capable of doing that, at least at present. That would be something.
Oh, interesting. So learning how to learn, like
Yeah,
really.
learning how to
Okay, good. Interesting point. Okay, any?
Yeah, thank you. Some words about the process is very interesting and it's curious. What's the real meaning of the word of the description when what's the real use when you employ the word semantic for describing of this process? In particular, I think that semantics in this context, machine learning context, is similar to concept, and I think that you prioritize the use, the abstraction, and the learning of conceptual information, because semantics. Well, I am a linguist, so I feel that semantics is very, very word inserted in the framework of linguistics. But it is curious because of the exposition of the Professor Yi, you show conceptual information obtained by image and vision. So yes, it's complementary to other possible knowledge, but I don't know what is it's possible the connection between linguistic information. So it is possible if you introduce an ontology and link the image and with the concept and so on. But turning to the question of how the humans do the learn and how the computers learn, this is true because humans are able to associate very easily the relation between image and concepts or linguistic concepts. But in the case of the machines, I don't know if semantic is the use or introduction of semantics a good idea for learning the concept, processing the concepts, or just only focus it in the conceptual information, and semantic is other thing. It's a human thing, so it's a language thing, or anyway, but these other things, I don't know.
Any comments, panel, on like seeing the semantics? So I think in CS terms, it's a limited. I think everything in we see like there's a limitation, right? There's an assumption, and then so here also I think in the way semantics or semantic web, the field has come out. There is a limitation the way they define.
But necessarily is a limitation. I think,
Yeah.
for example,
So
I don't know, the ideas proposed by Ryan, semantics and knowledge obviously have a relation, and you can now establish what is the specific difference. But for the machine, it's curious because at this moment, I think that all here works with knowledge in a separate ways. No, you have language information, you have visual information, you have perception information, and you need to implement a system that complement all this kind of information. So it's just conceptual, excuse me, or it's really semantics, or it's not semantic, it's all thing.
So I will just comment on a previous point about curriculum learning and learning the teacher thing. So there, I would just say that not everything has to be done by learning. So there is this whole area of automated software synthesis, okay, where they try to generate software from formal specification of requirement, okay. And if you can do that, then they have this series of refinements that they allow, and it will generate executable code. So if you think about learning someone to write a program for sorting, right, and there's a formal specification of what the requirement is, so there are ways people have actually figured out, and through logic and refinement. So my point is that there might be other ways beyond learning, or maybe synergistic with learning, through which we could do it. The question is, can we formally specify what we want to do? Just a food for thought.
So being specifically formalizing that, and that actually touches upon your question too, that I think that's where the most of the things goes, because we are interested in formalizing because we have to make machines do it. And so therefore the way humans understand semantics and the way we connect, I mean, machines are not good at relationships, we are good at relationship patterns. So I think that way really there is a constraint for it. So any last comments, panel, like, because I think we're almost at the end. So anything as a lesson that you want to make?
Exciting times. Thanks for organizing this. And I think,
okay. All right. The formal thing.
Yeah.
All right.
Machine learning cannot happen without semantics, and I think semantics also needs to loosen up in terms of the formal representation in tools. So for a long time, tools in semantic reasoning has been separate from what mainstream IT has been doing. So I think more synergistic usage at the tool level is needed, so that you can build such systems.
Excellent practical point. Any other thing?
Not leave it with machine learning can't work without semantics. There's been evidence to the contrary. I think it's more to say that there's opportunities to go further by combining.
Okay, excellent.
It's very interesting and also very exciting to combine machine learning into the knowledge generation process. So probably just like a human combined together.
Excellent. So let's thank the panel for giving us some food for thought and some lessons. We will have a summary of this. We're going to write about it and also share with you. We'll also request all the presenters to give us a presentation, and we'll put that on the workshop website as well. And then we'll have, I think, abstract summary also in the AI magazine. So we're going to include these lessons that we have.
Thank you.
Thank you, Biplav. Thank you so much. Yes, thank you so much.
Thank you.
Yes, so thanks everyone for joining us, and I think this was a great brainstorming and learning on this topic, the exciting topic. So there are more exciting times going forward that we'll see.
Hello.
Yeah, really. Yes. Okay. I can get the back.